I'm not going to lie to you, folks. This limiting reagent is some stuff. Limiting reagents are some things that folks have trouble visualizing. So, it is a little bit difficult to understand. So I'm going to, just like when we talked about the mole, okay, I gave you an example that you're a little more familiar with. I'm going to use this example that I have up here. Limiting reagents. Now let's pretend that this is a chemical equation. All right? I have one case of water reacting with 2 boxes of Hawaiian punch, looks like fruit punch mix. All right? Now, what limits my reaction? What limits my reaction? Well, I look at this. How many bottles are in a case of water? 24. Anybody know anything about fruit juice packets? There are 8 packets in each box. So, what limits my fruit punch making? The amount of fruit punch. Why does it limit it? I only have how much fruit punch? 16 packs. How much water do I have? 24. So what am I running out with first? What am I running out of? Fruit punch mix. What do I have excess of? What do I have left over? Water. Specifically how much? 8 waters. That's the whole point here, folks. Something limits our chemical reaction. Something limits the reaction. Something is usually left over. Do you think when we're talking about these reactions that they occur just perfectly? You have just the right amount of reactant A to go along with reactant B? Doesn't happen like that. Okay? So, let's look at this example once again. Okay? We have 24 water. We only have 8 and 8, 16 packets. So, the limiting agent here is the drink packets because it limits my ability to make fruit punch. Yeah. No, this is another part of stoichiometry. Okay? It's another part of stoichiometry. Now, with that, we are going to go into limiting reagents in chemical reactions. So, here is the first problem. I'll give you a second here to write the problem down, and then we're going to work it. Okay, the question states, this is excess/limiting reagent examples. If 100.0 grams of sulfuric acid reacts with 100.0 grams of calcium carbonate to produce calcium sulfate, water, and carbon dioxide, how many grams of calcium sulfate are produced? Now, what do you think the chances are that 100 grams of sulfuric acid react exactly with 100 grams of calcium carbonate? Pretty low? I would agree. Okay? It's not going to be perfect. So something is going to limit this reaction. But we don't know what yet, do we? We don't know what. First thing that I am going to do is I am going to write my balanced chemical equation. So, I know that sulfuric acid reacts with calcium carbonate to yield calcium sulfate, water, carbon dioxide. Now, since I've already done this problem, I know that this equation is balanced as it is. So there is my balanced chemical equation. What I'm going to do is I need to pick one of the substances and go from a mass to mass. Pick one of the substances and go mass to mass. Well, I'm going to start with, and it doesn't matter, but I'm just going to pick H2SO4. Could I done the same exact thing and picked calcium carbonate? Yeah, I could have. Just randomly picked H2SO4. So, what I need you to do, and I'm going to do it also, okay, I need you to do a mass-to-mass conversion. I want you to go from sulfuric acid, H2SO4, to calcium carbonate. A mass-to-mass problem. You know how to do it. Go ahead and do it. Okay, I have set up my conversions. I make sure my cancellations are good. Which they are. So my final is going to be grams of CaCO3. So as I do my math, and I get my answer, I need to have 4 sig figs, You should have got your answer to be 102.0 grams of calcium carbonate. Now, what does this tell me? What does this tell me? It tells me that if I have 100 grams of sulfuric acid, how much calcium carbonate do I need to react with that exactly? 102. Do I have 102 grams? No, I do not. So what do I not have enough of? Calcium carbonate. So what is my limiting reagent? What is limiting my reaction? Calcium carbonate. Okay? Now, that has nothing to do with answering the question, does it? No. Okay? This just tells me where I need to start. Okay? Because did I use up all of my sulfuric acid? No. So if I would go mass of sulfuric acid to calcium sulfate, it would be wrong, because not all of that is used up. There is excess of it. So I need to take my limiting reagent and then go mass to mass. Okay? Because the original question was, how many grams of calcium sulfate are produced? In order to do that, I have to find what limits the reaction. And we all agreed, right? What limits this reaction? Calcium carbonate. So, now, what I'm going to do is I'm going to take calcium carbonate. Now, key point. Key point. Do I take 102 grams of calcium carbonate? No, because that's not what I have, right? How much calcium carbonate do I have? 100. So I'm going to take 100 grams of calcium carbonate, and I'm going to go mass to mass to calcium sulfate, because that's what they wanted me to find. So, do that. Right now, the first equation, I just got the limiting reagent. Okay? Now, I'm going from calcium. I determined that calcium carbonate was my limiting reagent. Now I'm going mass to mass from calcium carbonate to calcium sulfate, because that's what the question actually answered, or actually asked. So I have my problem set up. Once again, I've got to go through and check my cancellations. Calcium carbonate, calcium carbonate, calcium sulfate, calcium sulfate, is made with grams calcium sulfate, which I was trying to find. Once again, I go through. Four significant figures. Because I had 4 sig figs in the problem, I come up with an answer of 136.0 grams of calcium sulfate. Garrett. Okay, the question is, how do I know that 102 grams of calcium carbonate, it's not 102 grams of calcium carbonate that is the limiting reagent, okay? Calcium carbonate is the limiting reagent. I come back here. Let me go back up a little bit here, okay? When I started, remember when I started this whole problem, I had 100 grams of sulfuric acid and I had 100 grams of calcium carbonate. In order to react with 100 grams of sulfuric acid right here, in order to react with all of the 100 grams of sulfuric acid, I needed 102 grams of calcium carbonate. But did I have 102 grams? No, I only had 100. So that is the limiting reagent. That's the toughest part right there, people. The toughest part, being able to visualize that. I don't have enough calcium carbonate. I need how much more? 2 grams more, right? 2 grams more. So that's the toughest part of this. But nonetheless, okay, all we're doing is mass to mass, right? Just doing it a little bit differently. Let's work another one. Okay. I needed to determine, once again, okay, let's go back here. I needed to find out which one was totally used up and which one had some left over. Okay? Which got totally used up? Well, in this case, it was the calcium carbonate. Okay? So that's what this whole step in the red is right there. To determine which one I had left over, which one was there not enough of. Okay? Now, we're going to work another one, because like I said, I know this stuff is not easy. So go ahead and copy this down. Once you get it copied, we'll roll from there. Okay, now that you have this copied down, it says a 5.0 gram sample hydrochloric acid reacts with a 24.0 grams of magnesium hydroxide. How many grams of magnesium chloride will be produced? Okay. This is a specific type of a double replacement reaction. This is a neutralization reaction. So as I go through and get my chemical equation, hydrochloric acid reacts with magnesium hydroxide, and it yields magnesium chloride and water. So I need to go through and balance this chemical equation. I can see that I'm definitely going to need a 2 there, because I have 2 hydrogens and 2 chlorines. I would imagine that means that I'm going to need 2 waters also. So as I put that in, 2 4 hydrogens, 2 oxygens, 2 oxygens, 2 chlorines, 1 magnesium. I'm balanced. So I have my balanced chemical equation. Now, it does not matter which one I start with, okay? Doesn't matter which one I start with, so I'm just going to go with the first one given to me. 5.0 grams hydrochloric acid. Now, what am I going mass to mass to? What's my first step here? Go mass to mass to what? Magnesium hydroxide, because I need to determine which one of my reactants is limiting this problem. So, as I do so, set up my conversion box, and I know okay, I've set up my problem. I'm going to go back through and make sure that I get the appropriate units to cancel again. HCl, moles of magnesium hydroxide, moles of magnesium hydroxide. So my final answer right here is going to be in grams, mg, OH, I do the math involved. And I'm going to go I'm going to go right here just to sig fig it. I wouldn't need to, but I am going to sig fig it. When I did my math, this comes out to 4.0 grams of magnesium hydroxide. Okay, when I actually did my math in the calculator, I got 3.998777787. Okay, rounding it to 2 sig figs, it gives me 4.0. Now, once again, key part. What do I have too much of? What do I have not enough of? Okay, or what limits the reaction? I'm looking, if I have 5 grams, of hydrochloric acid, those 5 grams will react with 4 grams of magnesium hydroxide. Do I have 4 grams of magnesium hydroxide? Yeah, I got way too much magnesium hydroxide, don't I? How much magnesium hydroxide is left over? 20 grams. So when I react this 5 grams 20 grams left over. So what limits this reaction? Hydrochloric acid, HCl. So now, when I'm going to determine the grams of magnesium chloride that is produced, I'm going to use hydrochloric acid and go mass to mass. So I extend my page here a bit. So I'm going to take 5 grams HCl. And I'm going to go mass to mass. What was I trying to find? Magnesium chloride, if I remember right, correct? So I'm going to go mass to mass the magnesium chloride. Come through, make sure my labels are good. Final label is grams of magnesium chloride. And I'm going to use 2 significant figures. I come up with 6.5 grams of magnesium chloride. Now, what we're going to do, it's going to be somewhat similar almost to an entrance slip, but it's not, because I have a third example right here, only this is dealing with liters of oxygen instead of mass, okay? Liters instead of mass. What I would like for you to do, we're going to get a bell pretty soon here. What I would like for you to do is when you come back in after break, work this problem. Work this problem. Okay, there's some folks that are having trouble where to start at. Okay? I've got my balanced chemical equation. What I need to do is determine what is limiting this particular reaction. So how am I going to start this? Who can help me? Who can tell me my first step? Garrett, what's the first step you would do? He would take 45.0 liters of O2 and do what type of a process? Okay, but what are you doing? That's correct, but what are you doing? You're going to what? You're going from 45 liters of oxygen to where? Yes, you are. of what? Okay, the final product, what Garrett was getting at, he was going step by step by step by step. But the process you're doing first is you're going from liters of oxygen to grams of H2S, hydrosulfuric acid. That is your first step. Liters of oxygen, mole of oxygen, mole. My final answer is in grams, H2S. So when in my calculation, I come up with 34.2 grams of H2S. So what is limiting this reaction? What is my limiting reagent? So, let's look. Let's look at it. If I have 45 liters of oxygen, how much hydrosulfuric acid do I need? 34.2 grams. Do I have 34.2 grams? Yeah, I've got 35 grams, right? So you can even tell me how much hydrosulfuric acid is left over, can't you? How much is left over? 0.8 grams, right? So what's my limiting reagent? Oxygen. So now I'm going to take my oxygen and go mass to mass to sulfuric acid. So I'm going to take the 45.0 liters of oxygen, go mass to mass to sulfuric acid. Balanced chemical equation, that's 1 mole. acid. 45. Three significant figures. .5 grams of sulfuric acid would be produced in this specific equation. Yeah, Kyle? I agree with you. I should put that in there, okay? And I will. The question is, how do I know I can use 22.4 because it doesn't say it's at STP, okay? I should put that in there. You're right, and I will. Okay, because we need to have it at STP to use 22.4 liters. So I will add that, but that's a great point. Okay? Now, what I would like for you to do, folks, is active this morning was 7.3, stoichiometry, excess dash limiting reagent. All right? So, look at some of those on WebAssign. We're going to work another example of this tomorrow when you come in, and then you are going to do a gizmo on it. So hopefully that gizmo will give you a little bit more insight on limiting reagents too. But I want you to look at the WebAssign, or if you want to work on your 7.23 WebAssign. If that's not done yet, you have time right now to do so.